Alright guys, we're going to go over the questions from the most recent concept check, which was on integral applications. So all of these should have some tie-in to integrals. The first two are going to be IB questions that were non-calculator, or sorry, that were calculator active, and then the last one will be a non-calculator question. The first two will be shorter ones, about 6 marks, so 6 points, 6 minutes each, and then the last one will be a little bit longer, 14 minutes. And so we're going to try to get all of this done in less than that amount of time. Since I'm talking, it might take a little bit longer, but we'll see. All right, so let f of x equal cosine of x squared. Let g of x equal e to the x for negative 1.5 is less than or equal to x is less than or equal to 0.5. Find the area of the region enclosed by the graphs of f and g. So I need to find first what region is actually enclosed by these graphs. So we're going to pull up our calculator. We're going to go into y equals. I've taken the liberty of already writing the equations in here. So I got cosine of x squared for y1, and then I got e to the x for y2. Now I went in and I changed my window. I changed it because I knew that the x values could only be negative 1.5 to 0.5, and so I changed that for my minimum and maximum. I changed the scale so that it would be something reasonable for the scale that I have, so it goes, I'll give a mark every quarter now. And then because I know that cosine of x only goes up to 1, so now if I'm squaring those, well, you know, it's not going to get any bigger than 1 still. I'm still just doing the cosine. And so it shouldn't get any larger than 1 anyway. So I just went ahead and said, okay, well, maybe e to the x does get bigger, and so I'm going to go ahead and go up to 2 and down to negative 2. And so once I've got my window set up so that I can see the graph fairly well, we'll go ahead and push graph. All right, now on my graph, for some reason, it's got this little filled in area. But that's okay, you still get the idea. Here is the cosine graph, and there is the e to the x. Now if you get this and you have absolutely no idea which is which, you can always go into the trace function right here, and you push trace, and you just follow one of the lines along, and you'll see up here in the left hand corner it's saying y1 is cosine of x squared. So the line that I'm tracing right now is the cosine of x squared graph. Now you can see where the enclosed region is. It's from this intersection point here, all of that until this intersection point right here. Anything on the outside of that doesn't really matter. Is it still area? Yes, but it's not completely enclosed by these two graphs within this domain here. And so really that's the area that I want between those two intersection points. So that's going to give me a clue that I'm going to be taking an integral. Okay, now from where to where? I need to find these intersections. So we're going to go into calculate. We're going to go down to intersect, and now my first one is the first line, so I'll push enter. It's now asking for the second curve, which it's automatically giving me the e to the x. Now it wants me to guess, so I'm going to go over to the left here so that I get this left hand point and push enter, and it should calculate that intersection for me, which is negative 1.11. And so my integral needs to start at negative 1.11, and it needs to go until I get to the intersection right here. Now I actually know, because I understand cosine and e to the x, that they're going to cross right here at 1. Now you might be able to guess that. If you didn't know that for sure, you'd want to repeat this intersection process for that point. Just do the top line, the bottom line, and then get really close to this intersection, so it'll give you that point. But you'll find that it'll give you 0. If it doesn't, if it gives you something like something times 10 to the negative 13th power or something, recognize that something times 10 to the negative 13th is close enough to 0 for our reasoning. Okay, so that will be our next one. So I'm going to go from negative 1.11 to, well, the x value there would be 0. And so I'm going to go ahead and go to 0. Now I want to do the top curve minus the bottom one, because that will take this total area to the x-axis and then subtract this one, leaving us with the area inside. So it's always the top minus the bottom. Whether we're doing areas or volumes or anything else, it's always top minus bottom. So the top one here was the cosine curve. So I'll go cosine of x squared minus e to the x dx. Now when you go into your calculator, you can type it in this way if you want. So I can go fn int, which is in the F2 here, or you can get it from the math key, but you can go fn int, and then you can go negative 1.11. Fn stands for function integral. Okay, so then we go from negative 1.11 to 0, and then we type in the cosine of x squared minus e to the x, and I'll show you another way to do this in just a minute. Make sure that you tell it to do the integral with respect to x, and so when you push int, you've got 0.282. So the area equals 0.282 units squared. Okay, now I wanted to show you another way of doing this since I got another 20 seconds. You can actually do this whole thing without having to type in your functions. You've already typed them in to the y equals here, right? You typed in cosine of x squared, you typed in e to the x. So on this home screen, you can actually go into the integral and go from negative 1.11 to 0. And you can put here, if you go alpha f4, you can actually just put in y1, which was the cosine of x squared, minus y2, which is the e to the x. And so if you do that, dx, that will save you from having to write out the whole function. Now in this situation, it doesn't really matter too much because they're pretty short, but if you had a longer function there, like some type of quadratic, and you had 2 or 3 integrals that you had to do it for, it would be significantly faster to be able to just put in y1 and y2, and you'll notice that we get exactly the same answer. Sweet! Alright, so let's go on. That is our answer there, which we also did this way, negative 1.11 to 0 of y1 minus y2. Please remember that this will only work if that's the function you had in for y1 and that's the function you had for y2. Otherwise, you might have to change the order. Alright, let's look at the second question. I've only got 5 minutes for this one because I took 7 minutes on the first one. I got to keep in mind my timing. I don't want to go over my 12 minutes that IB would give me. So the velocity of a moving body at time t seconds is given by velocity equals 50 minus 10t. Alright, so velocity equals 50 minus 10t. Find its acceleration in meters per second squared. This just means meters per second squared. Remember, when something's on the bottom, you can actually move it to top and give it a negative exponent. Why they would do that, I honestly have absolutely no idea, but IB does that. They do this. Instead of saying meters per second, they say meters seconds to the negative first. So, alright, they can do whatever they want. It's their test. But anyway, we go on. We want to find the acceleration. Now, we actually learned about this before because we said, okay, displacement. If I start with distance or displacement, the change in my displacement, the change meaning the derivative, will give me the velocity, because velocity is the change in displacement, or the change in your position as time passes. How is your position changing? Now if you find out how the velocity is changing, that would be the second derivative, right? So we take the derivative again to get to acceleration. So to get from velocity to acceleration, I need to take the derivative, and so I will do that. I will find dv dt, which will equal, well, the derivative of a constant is 0. Here, I'm going to take the derivative of negative 10t, which will be negative 10. So there you go. That is your acceleration. That was so easy. Hopefully you got that one right. So now we go on to part B. Part B says the initial displacement S is 40 meters. Find an expression for S in terms of t. And so now we already did the derivative go this way. We now want a function for S. Well, we have one for V. So to get from S to V, we do the derivative. So to get from V to S, we're going to integrate. So we're going to integrate here. We're going to go to the integral of the velocity, which was 50 minus 10t with respect to t. Alright, so we're going to take the integral. We don't have a region here, so remember this is an indefinite integral. We are going to need to add the c at the end because we don't know where we are. We just know how fast we're moving. So we take the integral of a constant will give me 50t. And then here the t will become t squared. And then I will divide by the 2, so 10 divided by 2 would be minus 5t squared, and of course I do need the c on the end. That will be the displacement. Now it did say in terms of t, not in terms of t and c, which means there's got to be some way that I can figure out what this is. Now here it says the initial displacement s is 40 meters. So initial refers to the fact that time is 0. That's the beginning. So if the initial displacement is 40, I can put 40 in for s and 0 in for t. So I go 40 equals 50 times 0 minus 5 times 0 squared. And so then those go away, and I've got 40 equals c. So I can write my final equation, which is s equals 50t minus 5t squared plus 40. Now if that irks you because it's not in standard form, you can go ahead and rearrange it so it looks like this. It doesn't irk me, it shouldn't irk you, but heck, some people just get irked easier than others, and so therefore you are welcome to rearrange it if you need to. Alright, so that only took me 4 minutes, which means I have saved 2 minutes now. Well, saved 1 minute overall because the first one took me 2 minutes. So let's move on to the next question, which was a 14-point question. No calculator, but because I saved a minute, I now have an extra minute on this one. So here we go. The diagram below shows the graphs f of x and g of x from 0 to 1.5. So f is the curve here, and g of x is a straight line, which, yes, that's a linear equation. Write down an expression for the vertical distance p between the graphs of f and g. Well, just note that p is the distance from here to there, right? Well, we know what value this is, right? You could figure it out if you really wanted to. That's whatever g of that value is, right? G, the y value, is right here. So this one is the same thing. This is just the y value, right? That's f of whatever value you put in. So the distance, the difference between these 2 points, is actually quite simple because we're just going to go g minus f. And so what is the expression for that vertical distance? Well, it's 10x plus 2 minus 1 plus e to the 2x. Done. That equals the distance p. Alright, so that simplifies things quite significantly. Given that p has a maximum value for this range, for this domain, find the value of x at which this occurs. Okay, so now they're saying there's some maximum value. Okay, well, p is a distance. If I want to find the maximum value, then really what I want to do is I want to find the derivative, right? The derivative will tell me where the maximum is, because it's going to, if I start here, it's going to get bigger and bigger and bigger, and then at some point it's going to stop getting bigger and it's going to start getting smaller. So if I were to graph a graph of p versus x, that distance is getting bigger, bigger, bigger. At some point around here, it's going to stop getting bigger and it's going to start getting smaller again. And so this is the graph of p versus x. At some point, there's a maximum, and at that maximum, oh no, it went away. Okay, at that maximum, that's where the derivative of p equals 0. You know that. You know that the maximum is where the derivative is 0. So let's go ahead and find that. Let's take the derivative of p. So we're going to go p prime. Now, maybe I'm going to simplify this a little bit. You don't really have to, but I'm going to go ahead and simplify. I'm going to go the plus 2 and the minus 1 will give me plus 1, and then it'll be minus e to the 2x. So let's go ahead and now find the derivative of p. So p prime equals 10, right? Because the derivative of 10x is 10. The derivative of 1 is 0, and the derivative of e to the 2x, so minus e to the 2x times the derivative of the inside, so minus 2e to the 2x. And so now I just need to find out when is the derivative 0. And so I'm just going to go 0 equals 10 minus 2e to the 2x. Because when the derivative is 0, that's when I get the maximum. Okay, so now we're going to find that maximum just by simply solving. So we'll subtract the 10. So I'll have negative 10 equals negative 2e to the 2x. I'll divide both sides by negative 2, so I'll have 5 equals e to the 2x. I need to get x by itself, so I need to get rid of this e here, so it'll be the natural log of 5 Natural log of this side will cancel out the e, so equals 2 to the x, 2 times x, and then divide by 2. So natural log of 5 over 2 equals x. So that right there is the value of x where the maximum occurs. So I did that in 4 minutes, which means I've saved myself another 2 minutes. So let's move on down. The graph of y equals f of x only is shown in the diagram below. So let's just make sure. Yep, there is f of x. And, oh, there it is. There's f of x. Awesome. So find f inverse of x. Okay, well, I need to remember what f of x was. It was 1 plus e to the 2x. So f of x is 1 minus e to the 2x, right? Double check. 1 minus e, 1 plus e to the 2x. Good thing I double checked. I would have got the wrong answer and you would have been completely confused. So we'll just do this. Now it wants us to find the inverse. Inverse means you switch the x and the y. So let's rewrite it as x equals 1 plus e to the 2y. I interchange the x and the y, f of x and y, just temporarily. I'll put it back later. So I'm going to subtract the 1. So x minus 1 equals e to the 2y. I need to get rid of the e's, so I'm going to natural log both sides. So natural log of x minus 1 equals 2y. You have to understand that e and natural log are inverses. If you don't, you won't be able to get the previous question, nor will you be able to get this one. Then we're going to divide by 2. So there you go. Natural log of x minus 1 over 2 is equal to f inverse. Okay, you got to put that back in. That is the new y inverse, which is f inverse of x. Now it says, hence, show that a equals natural log of 2. All right, well, before it said when a is x, when x is a, y is 5. So if before x equals a, y equals 5, now that means that we should be able to switch those, right? So for the new equation, when x equals 5, y should be equal to a. And so what we're going to do is we're going to go ahead and plug that in, and we will see what happens. So let's go ahead and we'll put those into our new function. And so I put 5 in for x, and we got natural log of 5. Here, let me change colors for you here. So I'm now working with the integral. I've got to do this fast because I'm running out of time. So 5 minus 1 over 2 equals f inverse, which is y. So that would then be a. And so now I'll do the natural log of 4 over 2 equals a. Natural log rules. This is natural log of 2 squared over 2 equals a. The 2 can go in front. So that's 2 natural log of 2 over 2 equals a. And the 2's cancel out, leaving me with the natural log of 2 equals a. Woo! All right, I'm going to pause it because I need to plug in. Otherwise, I'm not going to get through C. All right, now it says the region shaded in the diagram is rotated through 360 degrees about the x-axis. Write down an expression for the volume obtained. So you don't even have to work it out. It just wants you to write it down. Okay, so we've got that the volume, we know the volume is equal to the integral from a to b of pi f of x squared dx. And so really all you have to do is put in the f of x and the a and b. So the shaded region goes from 0 to a, and we just showed that a was natural log of 2. So volume equals the integral from 0 to the natural log of 2 of pi times the function. So this function, remember, was this right here, 1 plus e to the 2x squared, and then dx. So that is an expression. I don't know what else to say. You got the expression, you're done. If it says to evaluate, then you have to work it out. But this just says write down an expression, so you are done. I've completed the whole thing in 20 minutes, which means I saved 6 minutes for a hard problem later on. So that's even with all my babbling and talking and all that schmack. So anyway, there you go. Good luck on the next one, and I'll see you in class.